All right, everyone. Hopefully the mic and everything is a good volume for everyone today. So it is now 3:30, which means it is time for us to get started. Welcome to Comp 426 Modern Web Programming. I'm extremely excited to have you all here today to kick off another hopefully great semester. So if you are hopefully you're in the right place. If you're not, for whatever reason, this is Comp 426. And let me know as well if you have any questions about, because I've gotten a lot of questions in the beginning so far about enrollment. So if you have any questions about a waitlist or anything, let me know after class, and I'll be able to field for that. All right. So we're going to get started here with some introduction. So one feature of this course, which you'll see throughout the class and a little bit maybe today, but more so as we get started, is that this course will involve a decent amount of participation and collaboration between you all as classmates. My hope is that throughout this semester, you'll have the chance to talk to, work with, and learn from your peers throughout the course, as well as the instructional staff. Many of them are here today. So in the vein of this, I know some of you might be sitting with your friends, which is great. I'm glad you all were able to get in the same class. But you also might be sitting with people that you have not met before. The CS major, many of you are, I think most of you are majors. It's a very, very big major, so high chance that you don't know people. So we're going to give you the chance around 3 to 5 minutes here to spend some time to introduce yourself to your classmates. Feel free to share things like name, hometown, your year, if you did anything fun over summer break. And we'll get back in about 3 to 5 minutes, and we as the staff will also not be exempt from this, so we will introduce ourselves afterwards. So spend 3 to 5 minutes on this, and we'll get back together. We can kind of begin to come back together here. I hope you had the chance to maybe meet somebody new. Throughout the class, we'll have the chance to have a lot of different discussions regarding web programming in different ways. And so I think that'll be good. All right. So kind of perfect. We're, as I said in the beginning, we are not going to be exempt from this. Want to have the chance to introduce everybody. So this is this is our instructional team. This is team 426. I will kind of start off here. So hello, everyone. My name is Ajay Gandecha. I'm a graduate student here at the Department of Computer Science. Previously, I taught Comp 426 last semester. And before that, I was instructor of Comp 290, and I noticed that there are a few of you in this class who were in 290 last semester. So hello again. I hope that you're doing well, and I'm glad to have you back. And then before that, I was also involved in Comp 423, Foundations of Software Engineering, and 301 and Comp 210. All right. So we have an amazing team of TAs this semester. We had pretty much everyone in the team. I'm pretty sure, yes, everyone in the team was either involved in creating the course last semester or took the course and were created amazing things, amazing projects. And so we're very, very happy to have all of them here. And so I wanted to give them the chance to introduce themselves because you all will have the chance to get to talk with them. They will be in the classroom as well throughout our different lectures to help facilitate our conversations. So I think it makes sense to for those of the team who are here, we'll just go from left to right here. If you want to kind of stand where I am, TAs, and introduce yourself, don't be shy. We'll get started kind of in order here. So.
Dave, I'm going to be the graduating semester. This is my second semester as a grad student. I also am an undergrad here at UNC. I'm from North Carolina, and over the summer, aside from interning, I also went to Korea.
Perfect. Yeah.
Previously, I paid for last semester and one time under Jordan. I'm from Greensboro, North Carolina, and I did over the summer. This is what I thought before. Actually, I still probably.
I'm Ajay. I'm a 426 last grade, senior studying computer science and economics. From Winston-Salem, North Carolina. PA is a PA for 110 points, and this is 590. And now this class, this past summer, I was looking everyone. It's great to see you here, feeling good and yeah, this is something I'm going out here for. We're very excited about having this. So, yeah.
Hey everyone, I'm Helena. I'm currently a junior studying computer science and media journalism. My first time to for 426. I'm the Wilmington for the past 2 semesters. And past summer I was a political staff for engineering. Hi everyone, my name is Charlotte. I'm a junior and I've stayed for once in the past 3 semesters. This is my first semester on proficiency. And this summer I was also a software engineering intern at class with Gandecha.
Hi everyone, I'm Leo. I'm a junior. I'm from North Carolina. And this summer, I was interning at Banner from full-time development.
All right, thank you. Round of applause for the team. All right, so again, we have an amazing team this semester who will be there to help you all and support you throughout the class. I will also mention here, we have two who were not able to make it due to some circumstances today. I will say, so David took the class with us last semester. He was a previous TA for Comp 126, our non-major web development class, has done a lot of substantial work. And then Upashna was part of Team 426 last semester, the inaugural team, and also helped to build up the class. So we have a great team. There'll be more details on office hours and stuff and how that was going in the future. All right, so there we go. I think that mic off should be better. So I want to kind of round out here and talk about some course goals. This you'll also find on the syllabus, but I think it's useful for me to talk about because, of course, you're all here in 426. You probably want to know a little bit about what we are going to be doing this semester. And so, of course, this course is called 426 Modern Web Programming. Here I'm emphasizing the word modern. So we really want to, the goal of this class is to teach full stack web development. We have a special emphasis on things like tooling, modern tools, best practices, and industry prevalent technologies and methodologies as well. So we're going to be, there's going to be a full survey throughout the class in various different parts of all of these different things. Now, one of the key things with this is that we want students to be able to understand the architecture and the workflow of these type of applications. So that even if you are, let's say, in an internship or you're doing a real job somewhere, no matter what tools you're using, because there are so many, you'll find that in this course, there's so many different tools in web development, and web development is a very fast-moving field. There's new things coming out all the time, but if you understand the kind of the key pieces that we're working with, you'll be able to tackle any new tool and understand how it works. So that's one of our main goals. In addition, we'll be talking about both front end and back end concepts to build full stack applications. You will also have the chance, this is something that I am very, very excited to put in this course and was in the course also last semester, because we have a lot of very technical classes in our department where we talk a lot about programming methods. But one thing that is often left out and but still so important is design. And so we're going to be talking about this in this course. How do we design good applications from the user interface and user experience perspective? Right? We can make an application and its code extremely efficient. That's something like Comp 210 and Comp 550 really talk about. But in the end, what your users actually see is going to be the front end, the UI and their user experience. We're going to talk about this. We have a unique opportunity to bring that in this class. And also, another key thing, as I had mentioned, there are so many tools in the world of modern web programming. So many things are constantly coming out. And so one thing that we will also, and you'll build this skill throughout the semester, is reading documentation and kind of how to take this technical writing that is written by developers for developers and being able to make sense of it and then kind of extract what's useful out of it and learn how something works. So we're going to spend some time on that. And then finally, kind of the main goal is that we want to prepare students for internships, for industry careers in full stack development. No matter what part of the stack you work on, it's still, you'll find this very useful for that. Right? So in terms of course content, there are still, and you'll note here, there's this kind of red text here, some aspects of this schedule, and this is not really a schedule, this is more of just kind of a flow chart here, are still to be determined. So that's because this course, this is last semester, we taught it Monday, Wednesday, Friday. This semester, it's a Tuesday, Thursday class. And so kind of the timings for how things are getting put in might vary a little bit, but this is the key structure. We're breaking this course into modules. We're going to first talk about things like web programming fundamentals, really build a very strong foundation so that we can support all of the things that we're going to talk about later on. We'll move into talking about some modern frameworks and web app architectures. How do we build larger applications, make them more production ready? We're going to be talking about backend concepts. There's a lot of interesting things there of how we can actually power a lot of the key functionality of larger applications. Again, we'll talk about design. And then finally, we're going to talk about more advanced web programming topics to help round things out. This will include things like different tools that are really important to know. Might include things regarding using AI tools, etc. Right? Now, some disclaimers here. This course is brand new as of last semester. So last semester was the first semester ever of this course content. Everything was created from scratch for that semester. This is the second iteration of that. So the hope is that the course you're getting this time will be even more polished than that one. That's the hope, of course. And the truth is that we are co-creating this course together, with the instructional team, with you all, and the effort you put into this course really will help to impact the course in a very positive way. So, that is something there. It's a unique opportunity to be able to redesign these courses for more kind of the modern age of software engineering. Now, in addition, there's another note here, which I know some people are always a little bit unhappy to see about attendance. I'm going to try my best, though, to justify this. Attendance on Tuesday, Thursday will be a requirement. So how we're going to do this is there's going to be a small percentage of the grade that is going to be dedicated for attendance. We're going to have these checks each day just to make sure that you're here. Not graded for accuracy, just the fact that you all are here is good. There are many reasons as to why this is an extremely important part of this course. And I am entirely honest, I do not think that this course would be possible without this format. There's a few reasons. First, this course is designed to include many active learning activities. You'll be talking with other people. You'll be doing things here in class. There are numerous studies, both in the world of college education and CS Ed, computer science education, that really point to the effectiveness of active learning activities. And that's only possible if everybody is here and participating. So another really, really important thing, I have talked this summer with the amazing career services team here in the department, and the one thing that they stress a lot, and you see this even online in various different surveys of recruiters, is that communication skills and other soft skills are very, very vital for hiring. In fact, a lot of people and a lot of companies will prioritize that even over technical skills. Things like being able to communicate effectively, be able to talk through your ideas, and kind of be able to communicate more technical things, being present and focused. These are all very, very important things. There are many people, obviously as computer science majors who are potentially looking at career options, lead code, and all of that stuff is something that's emphasized a lot. But if you talk to a lot of recruiters, and the department has, it's not just solving those problems that is important. It is the process of how do you effectively talk with the person that you're interviewing, talking through how you're thinking and working through the problem. So it's really, really important. And with these activities in class, you'll have the chance to talk to each other, explain your thinking on different technical concepts. And that is a very, very good skill to build and will help to set all of you apart, hopefully, in that process. And so that's why this is such a vital part of this class. Now, you'll see here that we do give free absences because, of course, life happens. Various things, you might feel a bit sick. maybe you're commuting and your car broke down. Anything could happen, right? And so what we're going to have, there's three free absences, no questions asked. You do not need a university approved absence. You can miss and they'll just be dropped and there will be no questions there. Now, if you, of course, have university approved absences, you can use those too, and that will not count toward these three. And also, all lectures will be recorded and posted very, very quickly after the lecture. This is because you may miss a class, or even if you did attend the class but want to re-listen to something, I think it's really important to be able to have that resource there. So all of the videos will be posted as soon as possible. Of course, barring any terrible technical problems that happen along the way. And even in those cases, last semester was a time where that happened. I can always re-record something after the fact to try and make up for it, right? I will pause here for a second, just ask if there's any questions on this. Perfect. All right. So grade breakdown, I'm sure everyone is interested in this. So this is how our breakdown looks. That kind of engagement part of the class that I talked about with attendance, that'll be 10%. Reading assignments will be 10%. We'll have many different projects, coding projects of web apps throughout the class. It'll be 30%. We'll have 2 midterms. The dates are on the website. They're very small weight. This is just here so that you're all able to kind of keep up to date with the content and whatnot. But students last semester, it went well for them. So the goal is not to stress everyone out. The goal is just to make sure people keep up to date on things. And then finally, a final project where you'll build a full stack web application that you'll be able to even talk about. You'll be able to present it and even share in the future if you would like. Now, a little bit about some materials here. So if you saw the Canvas already, hopefully everyone is in the Canvas, unless you're not enrolled in the class. If you get enrolled, you'll automatically appear in Canvas. But we're not really going to be using Canvas for anything except for announcements. And then at the final last week of class, we put in all the grades are going to Canvas. Everything else, the single source of truth for this class will be the course website. So I'm going to open up the website here. It's been redesigned this semester. So there we go. This is what the website will look like. We have different pieces here. You can see important links. We have syllabus, team, some extra resources, and office hours. I will note here real quick, because I said in the beginning I would, office hours will start that on Monday, I believe, but the schedule will be posted. There'll be a calendar there. We use the CSXL site for office hours like most of the other courses. And so we'll have this up as soon as we can. I'll send an announcement once the schedule is ready in case you want to write it down. And then we'll have kind of information here. So I'll have like assignments. We'll have the course schedule. So we have slides you'll see here. Another thing is that you should see over here where I'm circling, there will be a recording link that's posted soon after class. All right. And so again, whoops, not me to print there. Let's see here. There we go. So the website is available at comp42625f.github.io. And then in addition, all readings and assignments will be submitted through Gradescope. Now, I refreshed Gradescope recently, except I'm going to refresh it again. So if you don't see yourself in there, don't worry. I'm going to do that after class. I'm constantly refreshing it because I know people are joining and leaving. All right, any questions here? All right, amazing. So we have quite a bit of time left. So we're going to get started talking about some content today that's going to really help to set up a lot of what we are going to be talking about with building these web applications and working with websites in the semester. So we're going to start off here with our module on fundamentals. We're going to talk a little bit about the internet. All right. So, and I do apologize. You might see me in the beginning of this semester drinking water. I'm used to teaching the 50-minute class about 75 minutes, so it's a little bit longer. But hopefully my voice does not give out on me today. Otherwise, I might have to increase the volume. All right, so we're going to get started talking about the internet. So again, this is our course title. It's Modern Web Programming. This time I'm emphasizing the word web, right? We are building applications for the web. So what do we mean by the web? Well, web is kind of the short term for what we call the World Wide Web, WWW, or W3 in different cases is what it's called. And all the web is just an information system. It's a system that enables us to share information across what we call the internet. What is the internet? Well, the internet comes from this terminology here, interconnected network. The internet is just a network, an interconnected network of all of the computers around the world. And just to be very clear here, when I say network, a network is just any communication or connection between two or more computers, right? So again, World Wide Web, sharing content between all of the different devices or computers on the internet network. All right. Now, one important thing to note here is, and this is always an interesting thing to think about, and there's actually classes that kind of go into this a little bit more. When we talk about computers, computers are not, we have our typical laptops and desktops as things that we think about computers, but it's important to remember that any device that can connect to the internet. There's various different ones. There are tablets, there are phones. There are things like washing machines these days that connect to the internet and send you notifications when your clothes are done. Like your, like Nintendo gaming consoles. These are all computers and they all connect to the network. So it's important to note that any electronic device that can connect to the internet here is what I am referring to, not just computers. And for a little bit of trivia, we have a old, I don't think anyone has probably seen this, but this is actually the logo for the World Wide Web. You can tell it's a bit retro, so it probably has not been commonly seen recently. All right. So when I say the internet again, connected network of computers, this is what this might look like at a really abstracted way, right? We have we have computer here, we have a phone, we have our internet-powered washing machine over here. These are all part of the network, right? Now, if you're thinking about this, the entire point of the web is so that computers on the network can communicate with each other, right? But we need to have a way to be able to identify the devices on the network, right? If I am one computer, let's say I am this computer, and I'm trying to talk to another computer, I need to know, how I need to be able to find that computer, and we find it with a unique identifier, right? We need a way to identify these devices. And we do this using something called an IP address. Many of you have already heard of this terminology, IP address. All an IP address is it's just a series of numbers, ultimately, right, bits that are being sent off that identify a device on a network, right? These are unique, so you can see there are different ones, and unique is a bit of a, I'm kind of glossing over some intricacies here, but for the point of what we're talking about, these are unique addresses. You can think of this, and the most kind of, I guess the most accessible analogy for this is just like on a road network, like we have Chapel Hill as a road network, 201 South Columbia Street, that is the address of Citizen Hall. If somebody is trying to send a letter to Citizen Hall, they know where it is because of that address, right? So it's very important that we have a way to identify nodes on this network. Any questions here? All right. So we now have a way to identify the devices on this network, but how do these devices actually communicate, right? Right now I just have an arrow. How does this communication actually happen? And so the entire premise of how the web works ultimately, and this is a model we're always going to be coming back to in class, which is why it's on the first day, is that computers kind of talk to each other using this, what we call this request response model, right? So a computer, if it wants to talk to another computer, get some information from some other computer on the network, it's going to request resources from that computer. Right, so you can see here that I have one computer here. I want something from over there. So this computer will request some resource, and then our destination computer will respond back. Right. So again, we have one computer request resources, another responds with it. What do we mean by resources is probably a good question that you might be thinking of. And it could be pretty much any of these different types of files that we would interact with on the internet. So things like images, files, data, even websites, right? That's what we're going to be leading to. These are all resources that are shared between these computers. Any questions here so far? All right. Now, I will note here that there's a lot of kind of terminology that is being thrown. I want you, though, to mainly just pay attention to kind of the base idea here, which is just that we have these two devices. One requests something from the other computer, and the other computer gives it back. That's really, that request response model is the main key thing here. All right. Any questions? All right. Now, I want to introduce another piece of terminology, which you have probably seen. That is a server. So again, if I go back here, we have two computers talking to each other. I can go even further back. There's all these different devices, right, on the network. These might be personal devices, right? This might be my laptop. That one over there might be one of my TA's laptops, right? This might be the washing machine in some dorm somewhere. These are all devices that are being used by people. But there are special types of computers that also exist on the network to do certain things. Particularly, the key one that we're going to be talking about is a server. Right, so a server is a specialized computer whose main job is just to give resources to other devices on the network. Right, so we went back here. We said that we had one computer requesting resources and another responds. Well, the main job of a server is just to get a request and then give a response back to another computer. You can kind of think of this like, like a server. We use this terminology in other places, like at a restaurant, right? You order food, then the server will maybe send something off to a chef to cook it, and then they'll bring you ultimately that food back. It's the same idea here. Of a computer requesting something, the server will ultimately give that resource back. Questions with this? All right. Another important thing here, and a term that we're going to use a lot, we introduced server. The other one is going to be called client. So a client is any computer. It's kind of the opposite, right? So it's a computer that requests resources from some server. So we have a computer, we have a server. In this particular diagram, which computer is requesting resources from a server? It's going to be this one. So this computer here will be called the client. Also, you can think of this in the real world context, right? If you are there's various businesses where you call somebody who walks into a business, right? They're your client and they're requesting some service from you. It's kind of the same type of idea here. That's where these terms can be kind of applied in the real world. We have a client and we have a server. Any questions? I want to make sure I'm not missing anything. All right. Oh, yeah. Now, one thing that's important here is that, right, we're sending information across the network. These are various, as we mentioned, there's so many different types of devices. There are computers. Those computers, like laptops, might be Windows. It might be there's all these, right, various different variations of computers, various different variations of operating systems and software. You have some like smaller, very embedded, like they call it embedded devices, like small little computers inside of something, your washing machine, something like that, right? And so it's important that in order for this communication to work, and in order for any various number of computers being able to communicate with the same server, these requests must be formatted in a way that both computers understand, right? Again, you can think of this like in the real world. If you go into a restaurant, you hopefully will try to order something, right, off of the menu, and you'd be speaking English, right? These are things that both people understand. If you try and go into, let's say, a restaurant and try to ask to buy a MacBook, they might look at you a bit funny, right? So that kind of idea is that servers need to, they're expecting some type of request. We need to make sure that the request is formatted in a way that everyone can understand. And so a common terminology that we use here in the web world, and if you took a networking course, I think like Comp 431, I'm sure they spend the entire semester on this idea, and this is known as a protocol. So a protocol, all it is just a predefined set of rules that is set. They're predefined, and that dictates how computers talk to each other, right? So if we set some sort of baseline, like some format that this is what a server expects, then every computer that's trying to request something from that server should follow those rules in order for the communication to be successful. So we have here a protocol. Questions with that? All right. In particular, the protocol that we're talking about and the protocol that is used to power a large part of the web is HTTP. You've probably seen this. If you go to any URL, a lot of you are on your computers right now in your browser. If you click on any of them, you'll see those letters HTTP in that URL, right? So HTTP stands for Hypertext Transfer Protocol, and it is a protocol that's used to make sure that this is a format that we're setting so that when a client is requesting data from a server, everyone understands how things should be formatted. So this protocol consists of two main parts. These two main parts are actually what we have already talked about at a high level, which is a request and a response, right? So we have, as we communicate using this protocol, we have two parts. We have a request that dictates how the format is set of a computer asking a server for something. And then we have a response, which is going to contain that resource, and that protocol, that part of it, will specify the format for what the computer should expect from the server, right? So it's a set format for how our request and our response should be formatted. Any questions of the high-level idea here? All right. So as I've noted here, the request and the response in all of these communications are formatted consistently every time, according to the set of rules that HTTP sets, right? That protocol sets. Now, the actual format we're not going to talk about right now. You will see it in the future, because you'll actually be able to see the content of the request and response between computers and servers. But for right now, all I want you to know and take away from this is that there is a format, and we call these things what we send. HTTP request goes from a client to a server, and then the HTTP response is what the server sends back to the client. Questions with this here? All right. Little side note, HTTPS, this is just a secure version of HTTP. So the content of our communications are encrypted when we use this protocol. And this is just important because this prevents kind of eavesdropping. So if there's two people communicating, you wouldn't want a third person to be able to snoop in. And so that the contents of what you're sending is only understood by the two parties that are trying to talk to each other. That's kind of the entire idea here. So HTTPS is actually the real protocol that we use for our communications on the web. If you try to go to a URL, we'll talk about this in a moment, but if you try to go to a URL that is like HTTP : and then 2 slashes, your browser will likely send an alert saying this connection is not private. Are you sure you want to proceed? Something like that. That's because it's not using HTTPS. So if you go to any website, you'll see, and I'll actually do this as a demo here. I realize that because of the way this room is, this is going to be very hard to do because I don't think I can, I can't make the window here any bigger. But you can try this out. So let's say I go to apple.com, right? And if I click on this, you'll see here it says HTTPS at the top. This is a secure connection. And I think what'll happen if I try HTTP is it's going to redirect me. Yeah, so you can see I tried using HTTP and it ended up defaulting HTTPS. So there are some apps though, if you try to go to them with HTTP, it'll show you a warning here. And I believe on some browsers, now unfortunately, I'm using Safari here, but if you use Chrome, I'm pretty sure on the left-hand side, there's like a little lock icon, and that will be very specific and tell you your connection is encrypted. All right? Questions here? Now, one thing that we just demonstrated is, okay, well, I have one, I'm jumping a little bit ahead here. This is our diagram. Again, all I'm going to label here is that our request and our response is using this protocol. Right? And so there we go. So this is our URL that we just went to. And you'll notice that we have in the front of our URL, we have HTTPS : and then 2 slashes. And so when we kind of communicate on the web, we use URLs, right, to request websites from a server. And so that's here. So you'll see that with HTTPS apple.com, the format of our URL is set such that what goes first is our protocol that we're using, which in this case is HTTPS. And then what's after that is what's called the domain. So the domain is like the human readable version of our website, right? Apple.com. It makes sense as us humans. We know it's connected to Apple, the company. Right? And so the key point here also that I want to highlight, which is our first bullet point, and this hopefully kind of can help us connect these two things, is that when we load a web page on our computer, right? Let's say I'm on my phone right here, and I type in apple.com, right? This is my client, because this is one device on the network, and I'm requesting the website from a server somewhere. So the actual website for apple.com is on a server, and I'm going to make a request for that website, and then the server is going to respond with the website so that I can show it on my screen. Right? That is how we have websites also updating, right? Because every time we're requesting a website, and so let's say that apple.com, Apple releases a new product, the version that we get from the server is going to be our new version. Right? And again, here, just a URL, you've all used this. URLs are just a way for our browser to, we're telling our browser, right, that we're trying to request some website, some resource. And so there's a format here for us to use. Any questions so far? All right. Another thing that you have very likely seen already is that after our domain, we can include a path, which is basically us being more specific about what specific thing we want from the server. So if we have a website like apple.com, but we want to see the page for the iPhone, we can add iPhone to the path. And what our browser receives from the server then is just the page for iPhone rather than for everything. And if we don't include any path, it's just going to take us to whatever they've defined the home page to be. So if I go to Apple here and demo this, and I type in iPhone, right, you'll see that I get the page for the iPhone. So this is not an advertisement, by the way, for Apple. All right. Any questions here so far? Right. So again, you've used, as long as you use the web, you have used URLs. This is just kind of breaking it down a little bit and talking about the different pieces. I already showed an example. Now, there might be a problem here that you've identified, right? All the way back from a few slides ago, we talked about the fact that we have a computer network, right? And that network has all these computers on them. We have servers on the network. And what we're saying is that, well, when I type in apple.com on my phone is requesting the website from some server somewhere. And the question is, what server are we requesting that website from? Right? If we go back here, all we've provided the browser is just a domain, right? A human readable name of some website. And that is not that's not specifying any particular server to make a request to. Right? So somehow what's happening is when we type in apple.com in our browser has to figure out where on the network that website is stored, right? What server that's being stored in. And so what our browser does whenever we type in a URL like this or a domain like apple.com, your browser makes use of this thing called DNS. DNS stands for Domain Name System. You can think of this like the address book. It is a mapping from a domain that's human readable, like apple.com over here. And I apologize, I don't think this pointer is probably showing up, but right here, right, apple.com. And what DNS does is it tells us what is the IP address of the server that stores this website, right? So this is a very important step, because if we are, again, trying to communicate with a server, we need to know where that server is. We need to be able to identify it. Right? Just like in a regular road network, we may have, I think this is a good example of this, is like Citizen Hall, right? If you are a first-year student, or you were a first-year student, and you heard that I have a class in Citizen Hall, right? That's great. Where is it? I don't, you have to find where it is, then you type it in, and then you get an address so that you know where to go. That's the same idea here. We need to have some actual address, and DNS helps our browser get that. So our browser, when we type in some domain, it will check and give us back an IP address of where that server is located. All right. What I would like you to do, there's a website down here. If it's not large enough, it's www.nslookup.io. This is a very fascinating website. I think this is a great example of what we're talking about here, right? So what this allows us to do is kind of simulates what our browser does with DNS. So we have a search bar, and let me type in apple.com in here. So just, right, we provide a domain. We said domain is what's in our URL, so apple.com. And now what you'll see here is that we have different, what we call records. So you see here, we have a record IPv4 address, and it tells us a IP address of some server on the internet, and this IP address is where our website files are coming from. So when our phone goes to, when we're typing in apple.com, all of this you don't see as a user. This happens right behind the scenes, but your browser goes to DNS, gets the IP address, and then will ask that IP address for the website. And so it's pretty cool because you can go in here and you actually see where these servers are located, right? We have the entire country, entire world. There's all these servers out there. And so you can see it makes sense that Apple's server is in California, in Cupertino, where they are based. Let's try something like unc.edu, right? So unc.edu, that is a website that we go to very often, right? Let's look at this record, right? Very interesting that even though we are here in North Carolina, if we're going to unc.edu, our phone is making a request to a server in California to get information or to get our website, right? So these servers are in various places around the country. Ideally, most of the time, we try to have our servers closer to our user just so that it doesn't take us as long to load something. In this case, it doesn't appear to be that way, but it's very fascinating to see where all these websites are actually existing, right? Where these servers are. I could go to something else. I think last semester I used Nintendo, and Nintendo is in Washington, right? So they actually have an office, I think, in Washington. So their server is, the server for US is probably there, and they might have other servers around, for their games and whatnot, but this is where their website is coming from, right? And so feel free to play around with this. It's really, really fascinating to see where these servers are around the country. And it kind of breaks our model a little bit, because we think that, if we have a website, like let's say UNC, that's a website that you'd think would be maybe even in this building or like coming out of somewhere, but no, there's a server in California where it's coming from. And I can actually go cs.unc.edu and see if that's the same. Yeah. So you can see it's very interesting. This is a great website to check out, and hopefully drives the point home here that even though we have some domain that we use very often, Microsoft.com, Apple.com, UNC.edu, our phone or any computer that we're trying to load that website for, we need to know where in the country, what server is storing this website so that we can actually retrieve it and show it on the browser. Are there any questions here? All right, perfect. So we will explore, we might explore this a little bit more. This is just something that I think is, it's part of the process of loading a web page, right? Where this is a web programming class, we're going to be building web apps, and so we need to have an idea of how we interact with web pages already every day before we can kind of get into talking about building them. So DNS. And also one thing you might be wondering, which is a little bit of a side tangent here, is like, okay, so we're making a request, whoops. We're making a request to some DNS server. Where is that server? And so your browser, and there's information, the browser knows, because these DNS servers, there are these various providers of this. Cloudflare, for example, we saw some of them actually there. It wrote like Apple had an Apple logo, Cloudflare. Sometimes like Fastly, I think is the one that UNC is connected to. And so there's all these different providers for DNS, and your browsers, there's a very complicated kind of process of how your browser finds it, but a lot of this information, the browser already has some of that information built in. So that's why we don't have to like make some request to figure out what server. There's many DNS servers out there that help browsers with this process. All right. Perfect. Now, all together. So this is now our final kind of diagram that I want to bring home today with regards of loading a web page and how we interact with the internet. Right? So for example, there we have user typing in apple.com into their browser. And what our browser does is it's going to say, okay, we have apple.com. We need to figure out what IP address this website is stored on. I will also note here, just a little bit of a caveat, is that your browser has a local cache as well. So like if you go to a website multiple times, your browser might keep track of where this IP address is. So it doesn't have to like spend all that time looking for it, especially if you go to that website very often. So that's just something to note. But regardless, we need to figure out the IP address for the server. And then after we have that, our computer can then request files from that server. And that is how ultimately, when you go to any website, you end up seeing the website on your device, because the files that are necessary for that website to show up were stored on the server, our computer asks for it, and then the server gives it back. All right, any questions with this? Amazing. Also, I will note here, just because this is kind of a longer segment, in class, today, there's a lot of kind of definitions and different things that we're bringing up, but we'll also have more kind of activities and chances to talk to each other as we start on Thursday, okay? Now, in particular, right, I'm using very vague terminology here, where I'm just saying that our computer is requesting some files from the server, and then the server responds with the website, in quotes. And what I mean here is, right, there's all these different files that help to make up our website that our browser needs. It needs those files in order to show the website on the screen. And so we're going to explore what these files are and how they're structured next class. But one thing that I'll note is that there is a reading that's opening today that you'll be able to use to or you'll be able to help get a bit of an introduction to what we're going to discuss on Thursday. And all right, I think we're back. It looks like this ran out of battery, so apologize there. So I want to give a note here. There's actually many students, some overachievers, who have already completed the syllabus part. So if you're already in grade school, you can do that. So we have two different reading assignments that are going out. The first one is just reading the syllabus. And there's a pre-course survey that I would like you to fill out. This is really helpful for me to figure out kind of the other courses that you're in, some prior experience, and that allows us to tailor the class and where we spend time, what we talk about, all that kind of stuff. Also things like exams, all that. So this is very helpful for us. So we ask you to fill that out by Friday. And then there's also another one opening on HTML and CSS, which is what we're going to be talking about next time. If you have never heard of these two things before, I would maybe recommend to just skim the reading before lecture on Thursday. That way, I don't just like today, there's a lot of kind of definitions and stuff, and I don't want Thursday to also kind of feel that bad. So if you have prior kind of, a lot of people have maybe seen HTML and CSS and various things before, so then you should be good. Otherwise, feel free to just look at the reading, but you don't have to complete it, until Sunday. Another thing I'll note here real quick is that the first kind of 2 weeks, we have a little bit, you'll see we already have 2 readings. We have slightly more readings in the first 2 weeks just because there's some introductory content. After that, though, we begin to kind of ease, like it becomes more spaced out. So don't worry too much. Happy FDoc part 2 for our Tuesday, Thursday classes. We'll see you back on Thursday. If you have any questions on anything, feel free to come to the front and we'd be happy to talk to you. See you then.